Hello, hello, hello. Hopefully you're all in the right room. It did say VFX Cloud Workflows, but I changed it to Cloud Workflows because loads of you guys are more sort of like, engineering-y types when they come to this event. So I thought I'd try and make it a little wider. So who am I? That's me. I've been doing this quite a long time. I like to think that I make pretty pictures, so I'm the opposite end of all the engineers. As long as it looks good to me, I'm a happy man. You guys that want it physically correct and accurate to within an inch of its life, that's all good as well. But for me, it's all about the pretty pictures. So I work for Escape Technology. Escape Technology is a reseller. We work in the VFX, architectural design, VR industries. So anybody that does a pretty picture, we are your friend, and we will learn and understand your pipeline, and we will come and help you. For me, at the minute, as you can see, light fields are super, super interesting. And if anybody knows what light fields are, I'd love to have a discussion afterwards, because they're very, very cool. So today, we are most going to talk about how we got to the cloud. So some of this might be a little bit suck eggs for some of you. Some of you might go, oh, yeah, we know all this stuff already. And later on, it will be a little bit more software. To begin with, it's a little bit more hardware. And there's a little bit of a history lesson in there as well, because I like to sort of go from base principles all the way through. Okay? So how did we get to the cloud? Well, funnily enough, we started on-premise, which is kind of oddly formed, but we did. As we went from 486 machines and we started to get those Pentium Duos and we got multiple-core machines, suddenly software couldn't really keep up with all these wonderful cores that were being added into the machine. Okay? So you've got all these massive compute machines. So if you've got guys that are working V-Ray, Arnold and all that today, yes, you take full advantage of them. But things like AutoCAD and Revit and all these wonderful packages do one core really, really well. And that's about it. What are the main points for people in industry at the minute? Well, you all work in projects and teams. And often there's some poor sod who's doing a project move or a team move or lifting machines, carrying machines around the building, and we know how expensive and time-consuming that can be. So this is how virtualization started to begin. Okay, it made life for IT a lot easier, centralizing a lot of stuff, and it meant that they're not lifting large, heavy boxes around all over the place. So as I've said, what we do today, hardware, operating system, and apps. Dead straightforward, simple. Machine, connected, off it went. But obviously, the machines now, we're up to 32 cores on a single socket. That's 64 cores in one box. There's not too many softwares out there that take advantage of that to that degree. So virtualization became the way forward. And obviously, some of you will have heard it as VDI. And obviously there's hypervisors and brokers which actually allow you to control that whole virtualization infrastructure. So what's the advantages of VDI and moving the pixels, not the data? So essentially, most of you work on a 1 gig network, is my guess. So you have a 1 gig fixed infrastructure within your building. None of you, I guess, measure your data in megabytes anymore. So you're going to measure your data in gigabytes. That little bit of Cat5 or Cat6 that you've got hanging out the back of your workstation, putting a Ferrari under there with all the toys, with all the machines and everything else that's in it, multiple graphics cards, NVMe drives, everything else, and then you put this little bit of string in the back, and the guy goes, well, it's no quicker at loading my data sets. Well, funnily enough, that little bit of string didn't change. So you're not loading your data at any faster rate. So what we have is the ability to say, well, stick the machine in the data center next to the storage. Whether it's a full physical machine or a virtual machine. If anybody wants to try one out, there's a virtual machine sitting on that desk right there with a Zero client hanging off of Amazon right now. Okay? It's just a workstation shipping pixels, not data. Okay? So what are the best bits about it? Well, I ripped this off of Microsoft's, but obviously protect against loss and leaks of sensitive corporate data. That little Zero client has no hard drive. I can only make the USB ports to a mouse and a keyboard. At that point, the only thing you can do is take a picture of the screen. That's how secure it is. So suddenly I've got massive security. The big advantages we've already mentioned, central administer and manage your desktops, means that we can spin up machines to take advantage of different other workflows, whatever you need it to do. You're saving resources. You've got one machine that's serving multiple users all at once. And this has been the way forward with VDI for a while. So banking does this. A lot of those types of places do this as well. So let's work through it. So machines start life on the desk with a connection to the server. That's where most people are. And that server either sits in the corner of the room to begin with until you get to a certain size and the server starts making too much noise, drives you around the bend, and someone decides, let's put it in a machine room. And suddenly that's moved out of the way and everything else is left on the desk still. The next stage on is virtualization. Was they took those machines and they joined the server in the machine room. So I got big fast networking, big ways of shipping pixels back to the head office. At that point, the machine room gets to a point where we've got aircon, stupid amounts of power in there. We get to a point where, do we build our own data center or do we do a colo? So what we do is we move all of our stuff into a data center off-site, and essentially we end up with private cloud. So you move all of your infrastructure from on-premise and you generally put it into a large data center at some point. If private cloud's born, then it's fairly obvious where the next stage is. I'll just use somebody else's cloud or somebody else's computer. So it normally looks kind of like this. Desktop, local machines connected to a server. Machine room, virtualized or remote, depending which way you go. Co-location, or if you're very rich and have a massive company, someone that's going to have a large data center out of town or somewhere wherever. And then the obvious one is next is cloud, and where we move out to cloud. So internet and cloud requirements, they're two different things now. Once upon a time, you just got an internet connection. That's all you would ever get, yeah? And you carve up the internet, and if you're really clever, you might put a quality of service on the internet connection to stop the guy who's using Aspira or FTP and smashing your entire network every time he dials out. Okay? But today, we're also now going to need a data pipe, a connection that just does data, and that's all it does. So that journey that you've seen, basically, as you move through your IT infrastructure, changes and changes and changes. And where is your investment going to happen? Do you invest in big pipes? Do you invest in more cooling, more power? At what point do you reach a tipping point that you suddenly need to change the way that you are working? So from a network standpoint, small companies, SMBs, are going to be looking maybe 1 gig internal network, as we've talked about. They might be a 100 meg or a 100 meg bearer for their internet connection, and that's all they do. And as you move up, you suddenly start to change the way that your infrastructure will work internally. So suddenly we've got the machine room. You've still got 1 gig to the desktop, but you might suddenly have a 10 gig or a 40 gig backbone on your servers and your main infrastructure. You might have 100 meg on 100 meg still. You might have 100 on a 1 gig bearer, whichever way it is. But as soon as you move from the machine room to a co-location and you put all your data in a data center, obviously they've got bigger pipes and they're cheaper because they're coming from the right locations. The next one on from that is cloud. And that's where the tipping point really starts to come in. So because I'm now no longer shipping data. So here I might have multiple connections of 10, 40, 50, 100 gig from my office to a data center location where I'm still loading data across that network. But as soon as I shift to cloud and I've got storage in the cloud, I've actually now just shipping pixels. I don't need this massive infrastructure to ship pixels across. So I've suddenly hit a tipping point where it makes more sense. Do I keep paying all the electricity bills, all the cooling bills, all my co-location fees, or do I just say, up sticks, let's put it into one of the 3 big 3s? Why no workstations? So workstations have avoided this wonderful thing for some considerable time. You know, most people have gone, oh yeah, but I do graphics. So my graphics is way more important than anything else. But a few years ago, NVIDIA released Grid. And NVIDIA Grid is essentially their virtualization for graphics. That's now in Amazon, Google, and in Azure. Their hardware, their technology stack is in that location. So you can take full advantage straight out of Amazon an NVIDIA Grid solution. For those who are familiar with it, you've got the K1, the K2, we're now up to the M60, the M40, lots of different graphics cards, completely dedicated to being carved up to deliver desktops. So the machine over there, if you want to try it in a bit, is based on an M60. An M60 gives you essentially 2 people on a GPU pass-through. Gives you an 8 gig graphics card, about the similar performance of a P4000, okay? So essentially you've got a really good graphics card, really good memory, and spin it up and spin it down as you want, powered by Grid. So the benefits, obviously, different ways of doing it with a remote workstation card, which is the physical piece of tin. But moving your workstation from your desk means you're not encumbered by the cabling anymore. It's just a pixel stream. Who has something similar to me, which is this wonderful paving slab of a laptop? Or do you go for a Chromebook? Nice and thin, super thin, ship the pixels. One day you can be using a machine with 8 gigs of RAM because you're doing Excel. The following day you could be using a machine with half a terabyte of RAM, 16 GPUs because you want to do a simulation or something very, very quickly. Data sizes and load times are increasing exponentially. So as we said earlier, you're measuring your data in gigabytes. And I'm guessing that if any of you guys are using the network or you manage a network at any facility, you're trying to load from central storage and trying to stop all your users utilizing their local SSDs or their NVMe drives that are outperforming by a country mile your 1 gig network and the central storage. So at that point, you've got guys working locally to work around the limitations of the infrastructure. We can outperform a single workstation now. You know, I can put whatever I want on the end of that pipe. I can put a render farm, CPU or GPU, remote from me and get more benefit from that than trying to use a single machine stuck under my desk. Okay? Virtualization is not just about trying to make loads of things fit on one machine. Use what you need when you need it, and obviously, again, security is massive. The fact is there's no data on a Chromebook, there's no data on your thin client, it's all retained centrally somewhere, whether you do it on your own cloud or a public cloud. So what about cloud workflows? So that's the sort of suck it and teach you, what you probably already know in some shape or form. But what this has got to is, allows us to really start to look at software-defined storage, software-defined networking, and software-defined complete infrastructures. What do I mean by software-defined? Essentially, there are no limits. So the one thing that I haven't mentioned is storage, okay? Storage is your Achilles heel to begin with in how we do workflows. And this is going to come on to rendering when I get round to that shortly. So, 2 flavors of workflow that are available to new companies and existing companies. We have hybrid workflows. A hybrid workflow is for those entrenched companies that already have storage, machines, networking infrastructure. Or if you're a new startup or doing a remote office, you could go born in the cloud. Completely everything in the cloud with minimal on-site infrastructure. As I said, that little thin client is doing all my work. Everything else is software defined up in the network, up in the cloud. Okay? So between these two, the thing that makes hybrid work is where your data is. So your data is the most important part of this problem going forward. Where do you put it? How do you put it? And how do you get access to it? So this is a software-defined storage solution called Pixstore. We also work with Cumulo, which both have solutions that run natively in Azure Amazon, and Google. So your storage can now seamlessly integrate from on-prem out into cloud storage archive solutions and allows you to actually use render farms that are either on-prem or in the cloud, a workstation on-prem in the cloud, accessing your data wherever it might be, whether it is on-premise or whether it is in a cloud. So you are 2 milliseconds away from Amazon's now 2 becoming 3 data centers here in London. At that point, I can spin up a workstation in Amazon and mount your own storage on your own network. I'll let that sink in for a minute. So yes, you can have a machine out in the cloud accessing your storage, mounting locally your internal storage infrastructure. Okay? You could do that with a render farm. I wouldn't recommend it because the render farm is going to smash your pipes to within an inch of its life, but you could do it. At that point, it's where you start to intelligently start to put your storage infrastructure. And this is where we start to stretch out. So with Pixstore, we have multiple ways of using what we call gateway nodes and what is also called PixCache. PixCache allows us to take storage and stretch it in very clever ways. So we can do what's called stubbing, which is essentially the header of the file, but the data lives on-prem. And only when it's called upon is it actually loaded by the cloud. We can also do reverse stubbing, and we can also do what's called PixCache. PixCache allows us to specify a volume or a set of directories that we want replicated inside of Amazon. So if I've got certain projects or I've got certain requirements like visualization, I can actually stretch that from on-prem out into the cloud and do whatever I want. So this is the hybrid workflow, okay? Now, hybrid workflows do require that you have the right storage infrastructure to be able to do that. But at that point, in my world, on a Friday afternoon, there's normally someone called a producer that walks in and says, we got 5 new starters on Monday, and they're being asked to expect or find machines, somewhere to sit, and all of the above. That happens in most architectural firms that I've walked into in some shape or form, and most design companies, because HR never tells anybody else until, oh, yeah, they're starting Monday. Don't worry about it, it's not a problem. At this point, if you can spin up workstations because you have none left, then at that point, all those problems go away. You can have on-demand workstations whenever you need them. The joy of this is that this storage allows you to stretch out, take advantage of all what you want in the cloud, and just use it as burst capacity. Okay? We are not condoning or saying that all that kit that you've got on-prem, you just need to get rid of today. That's not the way forward currently, you know. If you've got a project between 4 and 6 months, it's more cost-effective. We'll go into that in a second. So born in the cloud, we are seeing more and more companies that are attempting this workflow. Nothing on-prem, no workstations, no storage, do everything in the cloud for a project, spin it up and spin it down. We have our own OpenStack API that we've developed, which makes life real easy for starting, stopping workstations, creating render nodes and storage. We can spin up a complete infrastructure at the click of one button with software, so we have an orchestrated system. If you want to talk about it afterwards, I can, but I didn't want to go into product demo land, okay? Okay, so the other thing is that you can define the speed and the capacity of what you need for the job at hand. So if you're only building a small hen house, then you don't need a machine with 64 gigs of RAM, Revit, and everything else. So you can spin up the resources that you require. So you can actually get something that you want that does exactly what you need. So, cloud affects the way you work. And with great scale comes better working practices, which was something I was trying to come up with. If you have unlimited resources, suddenly you have to work slightly differently. And this is where our experience with the VFX companies comes in. So we deal with companies that have 3,000, 5,000, 10,000 render nodes accessing storage. Okay? Now on-prem, your render farms might be 20 machines, 40 machines, you know? That impact doesn't start to show up. The right resources, how you start to utilize it, and what works on premise generally starts to break as soon as you start going into the cloud. Yes, you can repeat what you do on premise in the cloud, but that's not a smart idea to do. This is where brokers come in. Again, a broker, for those who don't know, is basically a way of taking a username and connecting you to a resource. That's all a broker does. With that broker, you can be connected to your workstation that you have every day, or you could be connected to the machine you need that day. Okay, so if you were doing a simulation or you're doing a big render, you might need a really powerful machine just for the day, not the same machine for all tasks. So on-premise today, you'll be in somewhere in there. So this is sort of back to a little bit of history. So some places have single machines, and you've got that guy who renders stills all day. You know, I'm rendering, I'm just going for a coffee, fag, break, whatever, and we'll come back 2 hours later and go, look, finished. Got my render, it's wonderful. Or you'll have sort of realised that actually offloading that problem to a render farm is really clever, especially if you've got multiple guys doing visualization. We've done some good analysis of those numbers if you ever need any. And then obviously you're probably running 3ds Max or Maya with a renderer, Arnold, V-Ray, Octane, Redshift, RenderMan, whichever renderer you care to mention. And all of these are on-prem. Normally, any company that's under 30 people, under 50 people even, are often a Windows house only. Are we all Windows house users in the room, just out of interest? So some are, some aren't, and some are, some aren't. Right, okay. So Windows house users, essentially your render nodes have got Windows on it, your workstations have got Windows, and everything's there. And what you do is you load up 3ds Max, you load your scene, you put Arnold on it, or you put V-Ray on it, and you submit it to the farm. And on the farm we have 3ds Max, we have Maya, we have all the same applications that are on the workstation exist on the render farm. Okay, that's time-consuming and a real pain in the bum if you haven't got something like SCCM for the Microsoft installers, or you're using some sort of imaging software for the render farm, or you've got a really good IT guy who just sits there all day installing software on multiple render nodes. Okay? And everything that goes through that DCC application uses every file format under the sun. So it will be a PNG, a TIFF, a Targa, or whatever it might be that they push through. So we get all sorts of file formats that are running through that solution. So that's sort of somewhere someone in the room will be at, generally, unless you're really good. So render farm in the cloud is very different. So today there's a lot of people still doing a lift and shift, which is Zinc or Rebus or something like that, where it's like, I'm going to take all my data, lift it up, dump it into the cloud, let it render, and I'll pull some images back. I'm going to cross my fingers and hope that I turned all the lights on, I wasn't missing any textures, and I'm not going to have to render this again because I got it wrong, because it's going to cost me a load more money. So that's one way of working. The obvious way is what we've already mentioned, which is the hybrid centralization of your data. So if you've got the right storage infrastructure, you can actually start to look at just migrating your data out into the cloud, using something like ThinkBox Deadline to control how you spin up and spin down machines, which gives you a massive render farm. And the bottom one is the most interesting one. Obviously, if you run Windows and a workstation, and this is done in Amazon, 10 hours for 5 days a week, just to clarify some of the numbers up there, because you've probably all tried this yourself. But Windows workstation is about $450, okay? A week. Sorry, a month. Get it right? A month. Linux is $260 a month. Nearly half the price. Now you're all sitting there going, well, our software doesn't run on Linux, so we're not going to use it. That's stupid. Well, this is where we start to talk about more of pipelines and workflow and how things start to work. Okay? So, every CPU cycle counts and costs you money. Once you're in a cloud provider, every time. So let's look at 3ds Max or Maya. What is it actually doing? Well, what it actually does is it loads the scene file, you assign V-Ray textures to it. So as soon as you hit the render button, it is now converting all the data that was in Maya into a V-Ray native format. And it's doing that for your textures and the geometry every time. Okay? So as soon as you hit render, it's going, I'm going to convert them. Again, it might be clever and cache a little bit here, there, and everywhere, but 9 times out of 10, that's what it's doing. If I'm rendering an animation in Amazon or in Google or in Azure, the last thing I want is it, for every frame, to convert the geometry from Max or Maya to a format that V-Ray can read. Because if I'm doing that, I'm wasting money on lots and lots of machines. The other big problem with that is if I can spin up 1,000 machines, 1,000 machines are all going to try to talk to one Max file or one Maya file. How long is it before the 1,000th machine actually gets a chance to load that file? Yeah? If it's a 10-minute load time and we allow the file system something clever, it could be hours before the 1,000th machine actually does anything useful. But while it's running, it's costing you guys money. Okay? Obviously, 1,000 machines is fairly extreme, but for a visualization, if you want it done in a couple of hours, you can actually do it in the cloud. This is that unlimited resources again. Whether I use 10 machines for an hour or one machine for 10 hours, it's cost me the same amount of money. It makes no difference. So at that point, you can really start to change things. So this is where we use what we do with VFX guys to actually help you guys. So this is where we can export to an Arnold AS file. It's called a kick AS file pipeline. Yeah? AS files are the native file format for Arnold. Okay? And we kick out a frame per frame. So we don't make one Arnold file, because that would be bad. So if you've got 1,000 frames, we make 1,000 Arnold AS files. Okay? At that point, each machine goes, oh, I want that file. I want that file. This isn't revolutionary. This was developed 25 years ago by Pixar and RenderMan. It's called the RIB file. It's been around forever and a day. So essentially, what that means is that the storage works well, the infrastructure works well, I'm not converting the files anymore. The only other thing to make sure is to make sure that I'm using the correct texture file format. Because what has V-Ray or Arnold got to do to all the pings, targets, TIFFs, GIFs, or whatever anybody uses? It's converting them. So on 1,000 machines, you're converting the same texture maps again and again and again and again. And that's costing you money. Okay? Every time that texture's converted, you've done the same thing again and again. So what you really want is Arnold or V-Ray to load the scene, load the textures, and start rendering as soon as possible. And that's why we switch to these pipelines, because I don't have to install Max on an image. I don't have to install Maya on an image anymore. I just install the renderer that I'm interested in using, which means the image spins up faster inside of Amazon, Azure, or Google. It also means that I have better use of my licensing, and depending on whether you're using V-Ray or not, with our cloud solution, you can actually get V-Ray licensing on demand straight off the cloud. So you can actually bypass all the rental licensing that you might have to do yourselves. It also means that we can run Linux, because Arnold, V-Ray, and most of the renderers all run on Linux for a reason, because it's cheaper. If you've got 10,000 machines in your render farm, you are not going to put Microsoft Windows on there, because that's £100 a license. You can do the math. It's not a very clever thing to do. Equally, for you guys running cloud and doing this in this infrastructure, This is where we really, really urge you to start looking at your pipeline. Now, artists today, file, open, save, close. That's about all they ever do. That's not a pipeline. Yeah, it doesn't scale. It doesn't allow you to take advantage of what goes on in the cloud. It doesn't offer you any parallel workflows. It doesn't offer you anything useful. Okay? So educating the artists in how they run is pretty critical. So what sort of futures are there? So there's a whole new categorization of how we start to make machines fit into an ever smaller space with more efficiencies. So this is actually containerisation. Has anybody heard of containers? One up the back there. Cool. So containerisation is essentially called Docker at the moment. It's the sort of the market leader. Done a big arrangement with Microsoft now. So virtual machines, we showed you a similar picture earlier. You've got your hardware infrastructure, generally a hypervisor that sits on something, then your operating systems, your libraries, and your apps. You can see that's quite a lot. With Docker, what it allows you to do is make a container. So you can take application, render application, whatever it might be, pack it all up into a container, and throw it at whatever hardware you want. So if it's Maya, we can put it into a container, package it all up, throw it at a piece of hardware, and I'm going to be running Maya. It's going to send the pixels wherever I want it. I don't have to install Maya anymore. I don't have to do anything clever. I just throw containers around. At that point, a generic piece of hardware can be running any operating system it wants with a container service on it, and then I'm just throwing different containers. Doesn't matter anymore what is under each container. So at that point, I'm one stage further on than a virtual machine. I don't have to install the software. I don't have to have a guest operating system. I can develop in Linux and deliver it on Windows. So that pixel stream can just come straight through to you as something completely different. So at that point with containerization, I can take all of what we've discussed and make it even more efficient than what we've talked about now. So I could just take an Arnold render in a container, throw it at a machine, throw it the data, and it's rendering. I don't have to install anything. I don't need to make a virtual machine. I don't have to do anything clever whatsoever. So I've been talking at about 400 miles an hour, and we're 35 minutes in. I'm supposed to talk for 55 minutes, but I'm pretty sure that I've talked way faster than I thought I was. Yeah, there you go. So, any questions? Because it's like a small amount of people. Or have I talked utter rubbish and everybody's looking at me going, I have no idea what you just talked about? Yes?
When you're talking about converting geometry for V-Ray, you're talking about this. Cheers. When you're talking about converting geometry for V-Ray, you're talking about the V-Ray standalone, correct?
Yes, correct, yes.
Yeah.
So essentially you're exporting from the DCC. So the trick is to get as agnostic as you can from the application that's making the actual data. So if it's 3ds Max, you export to a VR scene file and let the standalone renderer do the work. You've not got to load 3ds Max into memory or Maya into memory. It just loads a nice small binary that's V-Ray or Arnold, and you're then rendering. So essentially, yes, all the standalone renderers in that fashion. And they all generally run on Linux as well now. So it's a great advantage to start looking at that. The biggest, most interesting part of switching between Windows and Linux is not the fact it's some scary monster thing. It's just making sure you understand how you do your pathing. So if you are a mounted drives house, X drive, S drive, whatever it might be, check out UNC paths, because UNC paths are your friend. / server name / project / name of data. Means it can be found anywhere on the network, and when S drive gets a bit small and you suddenly add another Y drive and all your paths start going wrong, this is what happens. UNC path names get away from that, and they also work really nicely in Linux land. So suddenly all your textures are found, everything works. With Linux 7.4, It's a very, very friendly thing. I urge you to play with it. It's good fun. Any other questions? Any hardcore visualizers in the room? Definitely. Any other hardcore visualizers in the room? No. Anybody else doing automation and pipelines? And obviously, feel free to try the workstation afterwards. Revit, AutoCAD, Navisworks, whatever you want runs in the cloud. It's just a computer. It's just sending pixels wherever you want it to be. So it's not a question of this is just for media and entertainment. It's for anything you want. Okay? And with containerization, you'll be able to take that one stage further and not even have to install the software. Okay? A lot of companies, such as the Foundry, are already containerizing all their applications. Okay? Money, that's a lovely one. We always like the money question. Where would you like to start on the money question? Right, so let's stop it right there. So, if I was to buy a new workstation that I was going to keep and use for the next 3 years, that would be a beautiful thing. And that is the best way to buy your hardware, without a doubt. The downside is such as companies like Jellyfish Pictures, where they got this wonderful dinosaur show that came on, they got 200 guys, they bought 200 machines, that project came to a grinding halt, the second one wasn't made, and they had 100 machines sitting there, twiddling their thumbs, costing them for the next 2 years. Yeah? So, as I said, it's got to be really judicial how you use the cloud. If it's a project that's 4 to 6 months, it's the perfect scenario. If you are setting up a brand new company, and that's what you want to do, then the cloud would require you to sort of say, well, am I going to in short-term projects that I can just throw it at? Or am I going to be building the new moving picture company, the mill, the new Zaha Hadid, then buy the tin? You will always need an element of physical on-prem tin until this gets as cheap as chips, and then you'll never buy another workstation in your life. We are talking to companies today that have bought their last workstations ever. They will only use cloud workstations against projects going forward. Now, the visual effects industry is very project-driven, and our projects are not 7 years, they're more like 7 months. Yeah? So it very much affects on what you're doing and how you would do it. So for you guys, you know, it's one of those choices. We're talking to an architectural firm at the minute that's got a little office that's going to be opening up in one location, their main office is in the other location. Will they be there in 6 months? Probably not. So at that point, it kind of makes sense to do it in the cloud and not throw a load of hardware at the problem. So monetarily wise, business-wise, you have to have in your mindset, is this a short-term project or a long-term goal of mine to make a big firm? If you're going to make a big firm and you want multiple users, buy the kit. We're more than happy to sell you it. It's not a problem. You know, that's easy. But the thing for us is trying to offer the flexibility. So for us, if you want to be super, super minimal, have nothing on-prem, then you can actually use the cloud to get you out of jail free while you're starting the company. At some point, once you've started the company and you've got some traction, you might buy some kit and then only burst, so on and so forth. Remember, all of what I've discussed can also happen on-prem. So we have what's called a remote workstation card. It sits inside a workstation and does all of what we're doing out of the cloud. We've done that for the last 10 years with people like the Moving Picture Company, who run their complete Paris office pretty much out of London. So in Paris, there is no hardware, just a monitor, a thin client, and a keyboard. Everything else lives in London. Okay? So satellite offices can be achieved. Oh, here we go.
Sorry, one more.
Tag team duo over there.
Node-based licensing. How do you manage that if your Mac ID is constantly changing, all sorts of stuff like that?
Tell me a company who still does node-based licensing.
Fume Effects.
Okay. So Fume Effects need to wake up and smell the coffee and not do node-based licensing. You know,
I mean, we're switching to, we do it now, but we're switching to a WebSocket, which is, that's what Adobe uses, so.
I'm all with it. You know, the thing is that there's always a sticking point with some piece of software somewhere, but that's not the reason to say that you wouldn't do it. You know, you need to have, with node-based licensing, you can treat it the same as any other workstation, and that's fine. You can even reserve that workstation, so that ID is solid. The other one would be virtual servers, because a lot of companies don't support virtual servers as a license server unless you specify that fact. So there are instances where you need to be very careful. Anything you can do on-prem, you can do in the cloud. It's just that it's not smart to do node-based licenses in the cloud, especially if it's going to die and go away. So I agree with you. But if you look at most of the companies out there that are big enough, then you would see that, you know, we've got V-Ray doing cloud licensing. The interesting one will be Arnold. Any Autodesk people in the room? Might turn the little switch there a little bit, you know. Come on, Autodesk, what are you doing with your cloud licensing on Arnold? But yeah, there's a lot of smiles going, yes, yes. There's none in there, I'm fine, it's all good. Oh, hang on, there's one, maybe. So I'm in trouble already. Any more questions? I didn't say it, though. It's an in-joke, don't worry. Cool. If you want to come chat afterwards, or if you want to play on the cloud workstation that's sitting over there, it's running on an Amazon instance out of Dublin. I'll make sure that it's up and running. Maya's installed on it. Other software that isn't Autodesk is also running on it. But either way. And feel free to come grab me afterwards. Hope it was useful. Thanks, guys.